Hello. Today we're going to be learning about isotopes. Our objectives are that you guys will be able to define the term isotope and differentiate between isotopes and atoms of an element. The essential question is, what are the differences between isotopes, ions, and atoms of an element? We'll be focusing on this essential question for about the rest of the unit. Isotopes are simply defined as atoms that have the same number of protons but a different number of neutrons. Examples of this include carbon 12 and carbon 14. If you look at this picture to the left, you'll see that we have four Bohr models of helium. Inside of each of these Bohr models of helium, you'll see that there are two protons. These are the red orbs with the plus signs. So you'll see two protons, two electrons for all four. However, the yellow orbs, the neutrons, change every time we look at a different Bohr model. Here they have three, here four, here five, and here six. What you'll also notice is that the name of the atom changes as we increase the number of neutrons. This is helium 5, helium 6, helium 7, and helium 8. So what is causing these name changes? It's the number of neutrons. To figure out the mass number, remember, we simply add the number of neutrons to the number of protons. As you increase the number of neutrons, the mass number increases. So why then do we write the name of the atom differently every time we change the mass number? Simple. That lets us know that we're dealing with what's called an isotope and not an atom. There are actually two different ways that we can write out isotopes. The easiest and perhaps most common is what we call isotope or isotopic notation, wherein you take either the chemical symbol of an element or its full name, write an M dash, and then write the new mass number. So in this instance, we're working with neon, which is chemical symbol Ne. We have an M dash and the mass number 21. Neon's mass number is typically 20. So this formation tells me right away that I'm dealing with an isotope of neon. Another way that we can write isotopes is in nuclear notation. Again, we've seen this before. This is very familiar to us. We have the chemical symbol for neon, that Ne, the atomic number shown here in blue, which is 10 for neon, and the mass number shown here in purple, which is 20 for neon, typically. If this were an isotope, say the isotope that we talked about on the prior page, this neon 21, we would simply write a 21 here instead of the 20. So now I want you guys to take a few moments and practice doing this yourself using what we call nuclear notation for the following elements: carbon, magnesium, and lead. So now I want you guys to take a few minutes and practice doing this yourself using what we call isotopic, and nuclear notation for carbon, magnesium, and lead. I'll go ahead and give you about a minute and 30 seconds to complete that. Okay, great. So now that we've had some time to practice writing these three elements out in both nuclear and isotopic notation, let's take a look at what that should look like. For carbon, you should have gotten an atomic number of 6 and a mass number of 12. This is what this should look like in nuclear notation. And here you have isotopic notation written as either carbon-12 or C-12. For magnesium, you should have gotten an atomic number of 12 and a mass number of 24. For its isotopic notation, you should have gotten magnesium 24 or Mg 24. For lead, you should have come up with an atomic number of 82 and a mass number of 207. For our isotopic notation, either lead-207 or Pb, which is lead's chemical symbol, -207. Great job. So, what is the atomic mass? We've already covered this, but just a quick reminder. It can be found on the periodic table of elements. The atomic mass is simply the weighted average mass of all of the atoms in a naturally occurring sample of the element. The atomic mass on the periodic table, this number at the bottom of the cube, the home of the element on the table, is reflective of both the mass and the relative abundance of all isotopes of a given element as they occur naturally. Just a quick reminder, isotopes will have different mass numbers than their standard counterparts. So for example, just to go back to the example of neon, where our isotopic notation was Ne-21, even though neon's typical atomic mass is neon 20. The reason why isotopes have different mass numbers is because they have more or less neutrons. Now I want you guys to take a little bit of time and practice filling in this chart here, which is in your notes, finding the chemical symbol, the atomic mass, the protons, the neutrons, and the electrons. I'll give you about 3 minutes to complete that. Great. Now that you've had time to practice filling in this chart, let's go ahead and compare and contrast our answers. This is what your chart should look like now. Notice that both samples of aluminum, aluminum 27 and aluminum 28, have the same chemical symbol, the same number of protons, the same number of electrons. The only two columns that are different are the atomic mass, which we know is this number at the back end of the element in isotopic notation, and the number of neutrons, because the mass number is simply the number of protons plus the number of neutrons. Again, the same thing is happening with copper, the same chemical symbol, the same number of protons, the same number of electrons. The only difference should be the atomic mass number and the number of neutrons. I chose two elements that were very similar to one, and I chose two isotopes of the same element. I'm sorry, because I wanted you all to see that the only thing that you should be changing when working with isotopes is the atomic mass number and the number of neutrons. Now you should have time to complete the independent practice. If you have any questions, I'll be available.